This is section 13, topic 1. And it is called the unit circle part 1. The target for this lesson says, how do you use your knowledge of special right triangles to find the angle measure of the angles formed by the rays intersecting the unit circle and coordinates of the unit circle. All right, so trigonometry, there's a lot of stuff that you learned in geometry that we use in trigonometry. Do y'all remember sine, cosine, and tangent? Yeah, do you remember what sine means? When you say, what's the sine of a certain angle? Do you remember that?
No.
You remember SOHCAHTOA?
No.
Nope?
Yeah, I remember that.
Okay. All right. Well, we'll be relearning that today. So, do you remember what a right triangle is?
Yeah.
What is it?
Triangle's a right angle.
What's a right angle?
90 degrees.
Exactly.
Jesus.
So, this is my right triangle. Okay. What is the side called directly across from the right angle?
What's the first letter?
Hypotenuse. Hypotenuse. If I'm referring, in the triangle that I drew, if I'm referring to this angle right here, I call that theta. Theta is the angle that I'm referring to. Okay? And any of these angles could be theta. All right? Generally, you're not talking about your right triangle. You're talking about one of the other angles. But if I'm referring to this angle, I need to know which side is opposite and which side is adjacent. Okay? So, the side directly across from the angle that I'm referring to would be the opposite or adjacent? Opposite side. And technically the hypotenuse is adjacent to this angle that I'm referring to right now, but hypotenuse, it can only be called hypotenuse. It's never the adjacent side, okay? And hypotenuse always is across from the right angle. So the other side would be the adjacent side. All right? And when we're talking about sine, cosine, and tangent, some teachers teach you how to remember it in different ways. But sine, cosine, and tangent is talking about the ratios of the sides, basically. Okay, so how I remember it is, and how I teach it is by saying SOHCAHTOA. Y'all ever kind of heard of SOHCAHTOA?
No.
S-O-H is the so part. Ca is C-A-H, and TOA.
Doesn't that stand for, sine and cosine?
Yes, yeah. Yep, which we're gonna write down. So the SOH part tells you how to find the sign. Okay, so the S stands for sine, S-I-N-E. The O is talking about the opposite side. And the H is referring to the hypotenuse. So basically, that means to find the sine, and sine, the abbreviation is SIN. To find the sine, you take the length of the opposite side and put it over the length of the hypotenuse. C-A-H. That's what we use to find our cosine. C-O-S-I-N-E. And to find the cosine, you take the length of the adjacent side and put it over the length of the hypotenuse. And cosine abbreviation is COS. So cosine equals adjacent over hypotenuse.
Is that Toki?
TOA. TOA. SOHCAHTOA. TOA. The T stands for tangent. To find the tangent of theta, you take the length of the opposite side and put it over the length of the adjacent side. And the abbreviation for tangent is TAN. So to find the tangent of angle theta, you take the opposite side and put it over the adjacent side. Alright, so you should have learned that in geometry. If not, I'm reteaching it all today, so no big deal. Alright, you also should have learned about special right triangles. So a right triangle is any triangle that has a 90-degree angle, right? But there are two special right triangles that we are going to use a lot when in our trigonometry unit. And that's the 45-45-90 degree triangle and the 30-60-90 triangle. Okay? So the 45-45-90, the two side lengths are congruent, and then of course you have the hypotenuse. And remember that the hypotenuse is the longest leg in a right triangle, right? And their legs have a relationship to each other. So the two shorts, let me label these angles. So your two short sides, we will call them S. So side length S. And if you know the measure of your short side, you just multiply your short side times the square root of 2, and that will give you your hypotenuse. So your hypotenuse would be S square root 2. So say the length of your short side was 5, the length of your hypotenuse would be 5 square root 2. Okay? If the length of your short side was 7.9, then the length of your hypotenuse would be 7.9 square root 2, and of course you could simplify that to get just one decimal. So this is a 45-45-90. That's what it's called. And then we have what's called the 30-60-90. So my smallest side should be across from my smallest angle. So if I'm just going by the way that I drew this, the way that it looks to me, this looks like the shorter side. So it's across from the smallest angle. And then the hypotenuse is the longest side. It's across from the 90-degree angle. And then the middle side would be across from the middle angle, which is 60 degrees. So the relationship, you might need to scoot up. The relationship between a 30, 60, 90, your shortest leg we refer to as S. The hypotenuse is twice as long as the short side, so 2S. And to find the middle side, you take your short side and multiply it by the square root of 3. And that we refer to a 30, 60, 90 triangle. Now how I remember, like, because one has a square root of 2, S square root of 2, and one has S square root of 3. The way I remember it is on a 45, 45, 90, you only have 2 side lengths, right? Because 2 are the same, and then you have that 1. So there's 2 different side lengths. So that reminds me that it's a 2 under there. On the other one, you have 3 different side lengths. None of these side lengths are the same, and that one has a 3 under the radical. So that's how I remember which one's S square root 2 and which one's S square root 3. That's just what I do, okay? I'm sure y'all already memorized it from algebra. All right, another big part of trig that we deal with, now if anybody's taking pre-calculus next year, you'll go much further into trig than we have to in algebra 2. But a big part of what we have to do is we need to know the unit circle inside out. All right, so that's going to take me to my next page. If you need something off of this, you can get it when we're finished. Okay, so this is called the unit circle. So draw a big old circle. And I'm going to draw an X and a Y axis and then on the unit circle. And the unit circle has a radius of 1. Okay, so like from the origin to the positive side of the x-axis, where my radius hits the unit circle, that's at positive 1. The ordered pair would be 1, 0, right? And then if you go to the negative side, if that radius is 1, on its ordered pair would be at negative 1, 0. When x is negative 1, y is 0. If this length is 1 up here, when x is 0, y would be positive 1. And if we go down to the negative side of the y-axis, when x is 0, y would be negative 1. So every radius on the unit circle has a length of 1. Now we're going to write a bunch of different things that we need to know about the unit circle. Okay? The unit circle has a radius of, what did we say? 1. That can be used to determine values of trigonometric functions. the unit circle is centered at the origin. Theta is the angle formed by the positive x-axis. And a ray that intersects the unit circle which is also called the terminal side, or which is called the terminal side. So like in my unit circle that I drew up there, from the origin, if I draw a ray that intersects the unit circle, the line that I just drew, well, hold on. So it intersects the unit circle here, right? From that point of intersection, I can draw a line that's perpendicular to the x-axis to make a right triangle. The ray that I drew, that is referred to as the terminal side of the triangle that I just formed, okay? And theta would be the angle that I formed when I made that triangle. Theta is always the angle that's formed from the origin, not any of the other angles in there when you're talking about the unit circle. All right. The angle measure is positive if the rotation of the terminal side is counterclockwise. So that terminal side, it can either swing counterclockwise or it can swing clockwise. If it's swinging counterclockwise, so that terminal, it always starts here at 1, 0. If it opens up counterclockwise, it's a positive angle. So maybe this angle has 45 degrees, let's say. If my terminal side opens and it's going in a clockwise rotation, it's a negative degree. So if I started from here and went 45 degrees this way, my theta here would be a negative 45 degree angle. Okay? So that's important to know. But you have to know what clockwise is and counterclockwise, right? So we need to write the clockwise part down. The angle measure is negative if the rotation of the terminal side is clockwise. If the base of the right triangle is x, and the height is y, the ordered pair at which the angle hits the circle is x comma y. So if I look back up at my circle, it says if the base is x and the height is y, then the ordered pair where the terminal side intersect with the unit circle would be at x comma y. That would be the ordered pair. And we're going to spend a lot of time finding those ordered pairs. Again, if you need the bottom of this, when I'm finished, you can look at my notes, okay? Just so we could move on, because I'm trying to get part 2 done today as well. All right. Another thing we need to know is the length of the hypotenuse formed in the unit circle. Okay. Here's my unit circle. Here's the triangle that I've formed. The terminal side in this case is the hypotenuse. What's the length of the hypotenuse? What's the length of a radius in a unit circle? 1. Is the terminal side not a radius of the circle? It is. So the hypotenuse has a length of 1, right? Okay. The length of the hypotenuse formed in the unit circle is 1. Now we're going to write the trigonometric functions. For theta in the unit circle. So remember, we have SOHCAHTOA, right? Let me draw a quick unit circle over here. a small one like I had on the previous page. Hypotenuse has a length of 1. The base of the triangle was x. The height was y. And then that little angle that we formed is your theta. So if we are finding the sine of theta, remember sine is opposite over hypotenuse. What leg is opposite of theta? Bring that to me. What leg is opposite of theta?
The right.
What do I have it labeled as?
Y.
Y. Over, or hypotenuse is what?
1.
1. So y over 1 is just y, right? So if I said what's the sine of theta, for short, it's going to be whatever the y value is. Okay, because if your hypotenuse is 1, now this only works for right triangles when the hypotenuse is 1. If you're just talking about some other triangle, but it's right triangles when the hypotenuse is 1. Okay? So your cosine of theta is going to be adjacent over hypotenuse. What leg is adjacent to theta?
X.
X. And what is the length of the hypotenuse?
1.
1. So x divided by 1 is just x, right? So if you were asked for the cosine of theta, you would just need to know the x value if you're talking about the unit circle. And then the tangent of theta is opposite over adjacent. So what leg is opposite of theta?
Y.
Over what leg is adjacent? What is it? X. Because yes, the hypotenuse is adjacent also, but it has a special name of hypotenuse, so it can't also be the adjacent one, right? So, and you can't reduce y over x right now anyway, with the numbers that we have. All right? So we can use, let me underline these. These are important. You need to memorize those without having to draw a triangle and write them down. How I remember cosine and sine, cosine comes first, C comes first in the alphabet, right? And X comes first in the alphabet. When I say comes first, I meant compared to the S in sine. So sine comes last and Y comes last. If you're comparing the two, that's how I remember. So like cosine is X, sine is Y. That's all I got. All right, maybe you can come up with your own way to remember them. And then tangent, Y over X. All right, so we can use these trig functions to find ordered pairs in the unit circle.
And these only apply to these type of circles.
Yes. Well, not the SOHCAHTOA thing if you had just a regular triangle, but it would have different lengths to it. The unit circle always has a hypotenuse of 1. So that when I'm talking about in the unit circle, the sine of theta is y. But say if we weren't in the unit circle and the hypotenuse had a length of 3, then we couldn't just say it was equal to the y value. Okay? We can use these trig functions to find ordered pairs on the unit circle. Let's find the signs of the function, of the function's value in each quadrant.
It says we can use 3.
These. All right, so sine of theta. I want to know what is the sine of theta in quadrant 1. So remember, when you have a graph, your quadrants, that upper right corner is quadrant 1, and it goes counterclockwise. So quadrant 1, 2, 3, 4, right? So the sine of theta is referring to the y values in the first quadrant. Are the y values in the first quadrant positive or negative?
And the what?
In the first quadrant of a graph,
Positive.
positive. Cosine of theta is talking about the x values. So are the x values in the first quadrant of a graph positive or negative?
What quadrant?
First quadrant, positive. The tangent would be the y values divided by the x values. So we already know y is positive, x is positive. Positive divided by positive would be positive, right? Now let's look at everything in quadrant 2. So quadrant 2 is the top left-hand corner, right? So sine of theta, sine's referring to your y values. Are the y values in this quadrant positive or negative? Y values. Y values. These are your y values. Positive. Cosine of theta are your x values. So are your x values in this quadrant positive or negative? Negative, right? Because it's that left side of the x-axis. So they're negative. Tangent are your y's divided by your x's. So that would be positive divided by negative is going to give you negative. Let's look at quadrant 3. That's that bottom left-hand quadrant. Sine of theta, your y values. In this quadrant, are they positive or negative? Negative. How about the cosine of theta in quadrant 3? Cosine's your x values. That means that you would get them from this part of the x-axis. Negative. And then tangent is y divided by x. So that would be negative divided by negative is going to give you a positive, right? Now let's look at quadrant 4. That's the bottom right quadrant. You can look at it. You know it's the x values come from the right side of the x-axis. Those are positive. The y values come from that bottom side of the y-axis. Those are negative, right? So would the sine of theta be positive or negative? Remember, sine are your y values.
Excuse me,
Yes?
do you have Eric Schofield?
He's not here today.
Thank you.
You're welcome. Screaming at me. So, the y values in this quadrant, are they positive or negative? Negative. Cosine of theta, the x values in quadrant 4, positive or negative? Positive. And tangent, y divided by x, that would be negative divided by positive is a negative. We cool with that? Okay. I'm recording this, so that's the end of topic 1, and I'm just going to pause the video because I want to do a different one for topic 2. And you don't have homework on topic 1, just topic 2. Not.
Why?
Why what?